Welcome back to this class. In this class, we are going to see some important questions from quantum chemistry. As I have told already, by solving more and more problems, you will get more confidence. In this way, I am giving some of the questions from quantum chemistry, and these questions are actually asked in the previous PGTRB exams. And the questions are: according to Bohr, the permitted orbitals are those for which the angular momentum, its value is mvr, has the possible values. For the mvr, the possible values are given in the options: h by 2 pi, 3h by 2 pi, 5h by 2 pi, and the fourth option is 2 pi by 3h. According to Bohr, the mvr values is likely nh by 2 pi. But in the options, h by 2 pi, the denominator, 2 pi is in the denominator. In the option 1, 2 and 3, it is in the denominator, but here in the option 4, it is in the numerator. So this option is the one which is not the possible values, but the remaining rest of the three options are the possible values. So this is the one is not the possible values. Now next we'll go to the next question. The expectation values of the psi operator H according to the postulates of quantum mechanics. This question is the direct questions from the postulates of quantum mechanics, so I have given only the answer. From the postulates of quantum mechanics, the value of psi, the Hamiltonian, is the integration between minus infinity to infinity psi h psi star dt divided by minus infinity to plus infinity integration psi star dt is the value for psi. I'll see the next question. This is one important calculation. The question is: a particle of mass 1 into 10 power minus 10 kg is confined to move in one-dimensional box of length 662 Armstrong unit. Its ground state energy is, the options are given here. They have asked about the ground state energy in a one-dimensional box. The formula to calculate the energy of one-dimensional box is E is equal to n square h square by 8 ml square. Since they have asked for the ground state, the value of n should be n is equal to 1. H is the Planck's constant, 6.62 into 10 power minus 34, and m is the mass of the particle. It is 1 into 10 power minus 10 kilogram, and L is the length of the one-dimensional box. It is 6.62 to 10 power. It is given as 662 Armstrong unit. When you convert this into meter, because it is in the meter and the answer is given in joules, so we have to convert this into meter. 6.62 into 10 power 12 meters. It is given as 662. When you convert this into meter, it will become 662 into 10 power minus 10 meter. So it will be 6.62 into 10 power minus 12 meter. When you put this in the equation, E is equal to, it is n value is 1 and the h value is 6.62 into 10 power 34 into 2 times 6.62 into 10 power 34, and the value is h. M is the mass of the particle, 1 into 10 power minus 10. It is already in the kilograms, and value of L, length of the box, is 6.62 into 10 power minus 12 meter. So when you cancel out this, the values will become 1 by 8 into 10 power minus 34, and the value in joule is, it will be in the joule. When you reduce this, 1.25 to 10 power minus 33 joules. This will be the answer for this questions. We'll go to the next question. The next question is: a particle is confined in one-dimensional box of length L. The probability of finding the particle in the region 0 to minus L by 2. The length of the box is given as L, but they have asked the probability of finding the particle in the box 0 to L by 2. In a one-dimensional box, this is a one-dimensional box of length 0 to L. Length is L. In the middle, we have the half of the L. L by 2 is the half of the L. Here the wave function will be in the maximum in the middle of the box in the ground state. This is the energy of the ground state is h square by 8 ml square, and the first excited state is, that means second level, is 4h square by 8 ml square. But here they have asked about the probability of finding the particle in between 0 to L by 2. So in the one-dimensional box, in the ground state, the probability is 1. When you calculate for 0 to L by 2, its probability should be half of the 1. So that means 0.5 is the option for this. Now the next question is, if E is equal to 3h square by 8 ml square, then match the following energy values with their degeneracy. So E value is given as 3h square by 8 ml square and the energies are given as 6E. Since E is given, we have to calculate for 6E, 12E and 21E. When you calculate the energy for 6E and 12E and 21E, the values will become, for E is 3h square by 8 ml square, and value for 6E, it should be 6 into 3 h square by 8 ml square will become 18h square by 8 ml square. Like that, for 12E, the values will become 36h square by 8 ml square, and for 21E, the values will become 63h square by 8 ml square. So from here, 6E, for the 6E values, when you put it in the formulas, and it should be in the three-dimensional box because the energy they have given is E is equal to 3h square. It will come in the three-dimensional box, 1 plus 1 whole square h square by 8 ml square. We will get the value of 3. That means, likewise, when you calculate for 6E level, that means 18h square by 8 ml square. When you calculate for this, we will get the value of 4 square plus 1 square plus 1 square. We will get 4 into 4 16 plus 1 square and 1 square. We will get 18h square by 8 ml square. So from this, these 4, 1, 1 will get 3 degenerate values. It is triply degenerate. Likewise, when you calculate for 12E in a three-dimensional box, for a 36h square by 8 ml square, we will get the value only for 4, 2 only. When you put this in a 3 different ways, 2 will come 4, 2, 4 and 2, 4, 4. 3 values will come. So 12E is also triply degenerate. Likewise, for 21E, the values will become 63h square by 8 ml square, but you can't get in any of the combinations to get the 63h square by 8 ml square. So this value is not possible. So it is non-degenerate. This is triply degenerate and this is also triply degenerate. Now I will go to the next question. The perturbation method can be applied if. The perturbation method is an approximation method to find the value in the real life situations. The perturbation method, the options are: a system is reversible, the system differs slightly from the unperturbed, and the energy wave function and the Hamiltonian of the unperturbed system is known. So these are the 3 options from this. Perturbation method can be applied only in between these 2 conditions. The system differs slightly from the unperturbed state, and the energy, wave function and Hamiltonian of the unperturbed system is known. If it is irreversible, we can't apply the perturbation, so this is the wrong option, and these 2 are the applied conditions to apply the perturbation methods. Now I will go to the next question. This is a straight question from the perturbation method. For the time independent non-degenerate perturbed system, this they asked for the time independent non-degenerate system. The expression for first order correction, the ground energy is, they have given the options. The first order energy correction is, they have asked the question straight away. The first order energy value will become, correction value will become integration of psi m, this is the level, psi m is the level and n is the level, psi m naught Hamiltonian psi n naught dt divided by em naught minus en. These are m and n are not the same. If the m and n are same, the whole value will become 0. Like that, we can also consider for the second order correction. The second order correction's value will become en, this is the superscript en to sigma I not equal to n. I should not be equal to n. These are the 2 values, 2 levels, I not equal to n. This is the modulus of integration of psi n naught h Hamiltonian psi I naught whole square divided by en naught minus ei. this n and I should not be the same. If it is same, the second order corrections will become 0. So these are the two things about the first order correction, the second order corrections for the energy level. I'll go to the next question. The valence bond theory, wave functions h of molecule is if psi ionic is 0.2 and the covalent part, for the ionic part they have given 0.2 and psi covalent part is 0.8 with the lambda as the ionicity parameter, with lambda as the ionicity parameter, and the value become in the ionicity parameter go with the ionic part. So the values become psi valence bond 0.8 minus 0.2, lambda is the options for the valence bond theory. I will go to the next question. The normalized state psi, this is the atomic orbital, this is a normalized state psi is constructed with a linear combination of atomic orbital to give the molecular orbital, combinations of the ground states psi naught, this is the molecular orbitals, and the first excited state psi 1 of the sum of the harmonic oscillators with the energies half and 3/2 units respectively. For the psi 1 you get 1/2, for the psi 1 you'll get 3/2 respectively. If the average energies of the states is psi is equal to 7/6, the probability of finding psi naught in psi will be, they are asked about the probability of finding molecular orbital in the atomic orbital will be, so the options are given as 1/2, 1/3, 1/4 and 1/5. This is a simple calculations. This is from the linear combinations of molecular orbitals. C1 and C2 are the constants of the molecular orbitals. Psi is equal to C1 psi naught plus C2 psi naught. These are the constants. From this, C1 square plus C2 square is equal to 1. This is the given condition. If C1, when you calculate the C1, C1 square will become half of the C2 square, half of C1 square, and C2 square will become 3/2 C2 square. This is the given in the this information is given in the questions, and psi is equal to 7/6. When you put this in the equations, in this equations half C1 square plus 3/2 C2 square is equal to 7/6. This is the equation 1. When you from these equations, in order to calculate in order to find out C1, from this equation C1, from the equation 1 multiply by 3/2 will get 3/2 C1 square plus, it will be like that, 3/2 C1 square plus 3/2 C2 square is equal to 3/2, and the second equation will be half C1 square 3/2 C2 square is equal to 7/6. From these equations, when you solve this, you will get the value of C1 will be, C1 square will be 1/3. This is the constant. So the probability of finding the orbital will be C1 square is equal to 1/3 for these questions. From the questions, from the options, 1/3 is the constant for the C1 constant. From the C1 constant, we can get the probability of finding the psi naught in the psi orbital will be 1/3. I will go to the next question. The radial part of the hydrogenic wave function is given as r alpha minus r into alpha minus r e power minus beta r. Alpha and beta are the constants. This is the wave function, r into alpha minus r e power minus beta r. This function is then identified as, the orbitals are given here, 2s, 3p, 4d and 5f. From these questions, we have to find out the order of r. From the order of r, in the radial part, this is the radial part. In the radial part, the wave function highest power of r denote the value of L. Here the value of order of L is 1, so it denotes the L is equal to 3p. That means it denotes that p orbitals. From the options we can get, since L is equal to 1, it will give the p orbital. So from the options we can get the p orbital is given here is, this is 2s, 3p, 4d and 5f. So the p orbital, for the p orbital the option will be 3p. So this is the answer for these questions. So far we have seen the questions from the quantum mechanics. In the next session we will see some other questions from quantum mechanics. So thank you so much for watching this session. Thank you.